You ready? Okay, good afternoon, everybody, and welcome to the anniversary event update about what's going on in the plant today. We've got some really interesting information for you that we hope that you like, and it's going to be primarily and almost exclusively focused on what goes on in our paint shop. So how do you paint a Corvette? A lot of detail and some of the processes and the sequencing that goes on, that's what we have to look forward to. You might have wondered why I have this laptop or maybe computer device here. John Elegant, who many of you may know, brought this up, and I thought that this was pretty cool. Who knows how many days, hours, minutes, and seconds it is until the Z06 reveal the end of October? Yeah, John does, and now I do. And if anybody can guess within a day, I'll give you a prize. 50 days? Who said 53? He needs a prize. This is what happens. You come to it's 53 days, 3 hours, 13 minutes and 44, 3, 2, 1 seconds. Okay, so what we're going to give him is, I'll just give it a little bit of a display here. This is a very special hat. The only time you can get this hat is if you are working within the Corvette assembly paint shop. The reason that it's very special is that it is absolutely guaranteed to be lint-free, because we don't like to bring lint into the paint shop, because then lint gets into the paint, and that is what drives Mr. Chuck Valentini, who's over here, crazy. And when he gets crazy, I get crazy. It's not good. So this is a very exclusive hat that you will now have. Okay, the next thing that I wanted to mention, who in the room might know what happened 30 years ago today? There's a couple people that have an inside track. No prize for this one, but do you remember what it was? I started working for GM 30 years ago today. So I guess that's kind of a personal milestone. I've already had people say that, that they thought I was going on 40. This place has aged me, believe me. All right, so let's get on with this material. The name of this presentation is a world-class paint job. And what you see in this photo is what we call the nerve center. And this is where every day Chuck Valentini, who runs the paint shop, if you didn't know, and runs the body shop, they get together every day and talk about what's going on, what they need to do. All right. Okay, and just as a reminder, Harlan was up just an hour and a half ago or so and talked about all of the 12 colors. Wanted to make sure that you all had a chance to see these. And as a reminder, the 3 colors that are new, we brought these to the bash, and they are out in back on a panel. And as Harlan mentioned, they're also on cars outside. So we started the paint shop with the capability to do 10 colors. Now we have 12 colors, and as Harlan mentioned, we always look to add these colors for all of you, so that you can find something that you might like to purchase. Okay, this is what the paint shop looked like when it wasn't there. Okay, this was the old paint shop. This is an aerial photograph, and you'll see the where we parked the cars there. This is what it looks like now, so you got to find a couple reference points. The pictures are a little bit oblique to one another. Just as a reminder, when we added the new paint shop, we also added some space for body shop. We almost doubled the size of the factory, and a lot of that was for the paint shop, and like I said, some for the body shop. So when you look at that picture, that second picture, all the area where you have a lighter colored roof, it's just because it's newer, the white, that's the new factory, the new addition that we put on. More than an addition, it was, like I said, it's like building another factory. So anyway, we're going to go through this presentation and we're going to have opportunities for some trivia. We have some more hats to give away, so you got the first one, and Chuck has volunteered to share those. So with that said, who might remember when the new paint shop came online? Just the year, no months. Keep going. Who said 17? 17. It was 2017 that this shop came online. Oh, yeah. And the other prizes that we have are some very unique things. Once again, you can't get them anywhere else. We have these little clips. And these are the clips that we hold the body panels onto the conveyors as they go through the paint shop. They get paint put on them, and they're kind of a unique thing. Once again, you can't get them anywhere else. We also use golf tees, and these golf tees are used to hold the panels on, and they also have, in this case, Accelerate yellow paint on them. If you were to grind this down, you would see all kinds of other colors because they get reused. And then we also have some little pieces of fascia that we paint, but then we cut off before we send those off. So we brought these as little paint examples. So we're just going to have these up here, and we're going to give some away throughout the course of the day just for some fun. Okay, let's keep going. I'm going wrong way. Okay, so this new paint shop, it's almost it's 800,000 square feet. You can almost say that it's 1 million square feet. It has 3 floors. It's the highest part in our plant, where we have 3 floors of active work that's going on. And you're going to see photographs of this and some video where we're moving parts up and down, back and forth through ovens, etc. We have 19 what we call VDLs. A VDL is a vertical displacement lift, and a layman's term for that would be elevator. We just don't use the term elevator because that has a connotation that you're moving people. It has other legal implications for regulatory reasons. So vertical displacement lifts, and we're moving these huge carriers. To be honest, this stage here is pretty close to the size of one of these, what we call a scuck, that holds the panels. So they're really, really large, and you're going to see some pictures of those too. Second question here. Anybody have any idea how many robots that we have? Who said 50? Right here. It's 51 actually, so you're close. We'll use the Price is Right. You got to be under, but you can't bid $1, which is done sometimes. So 51 robots, and these robots are doing all of the painting primarily. We do a couple other things with them. As you know, well, people haven't been in the plant for a long time, so you might not know, but we have a tremendous amount of robots in, not just in our paint shop, but in our body shop. Body shop is highly automated, and maybe the next presentation that we have, we do a little insight into that one. Okay, in the paint shop, there's 240 employees. We have 3 different panel suppliers, 2 that are delivering all the panels for the hatch, the fenders, the quarters, the doors, etc. And then we have 1 supplier that supplies the front and rear fascias. So 3 different suppliers. And then here's another question. Anybody have an idea who supplies the paint for the Corvette? Sherwin-Williams. No, not Sherman-Williams. No, it's like we are out of control, which I kind of like. Let's have some fun. That's why we did it. It's Axalta. So you may have seen on NASCAR teams Axalta there. That's the paint supplier that we have. Maybe you might remember DuPont, but now Axalta is the paint supplier that we have. And all the paints that we use, really, they are all formulated specifically for the applications that we have within our paint shop. So we don't share paint with any other factory, simply due to the things that we have to do inside our factory, primarily painting the composite panels. Okay, this is really kind of the first First question, the price of entry to get into the plant. Crater testing. Crater testing is a really interesting process. And you might ask, what's a crater? A crater, if you've ever seen, it's like the inverse of water beating up on your car wax. Imagine if you tried to wax a part that you're then going to try to paint. You're going to give these little craters, and those things are massively evil. So we do testing where we have every person every day that's in the factory do testing, and what we're really looking for is, as an example, if you have a deodorant or an antiperspirant or a perfume or some other, most of the time cosmetic-related chemical that's on your body or in your clothing, you could potentially completely destroy the paint shop process and wreck the paint job. So we have a process where we have a panel. We actually, rub it on all of our employees. That panel then is taken away. They paint it. If there's no craters, it's all good to go. If there is a crater, we go back to those individuals and we have to find out what is causing it because it could be very, very damaging. We have a very high standard for that. So like I said, any hygiene products, detergents, and perfumes. The other thing that we do, you'll see people in these videos walking around with these blue jumpsuits. They are the similar material that is used in the hats. They're lint-free, so they don't shed any materials. And we also, if you go into the shop, you have to have a hairnet or a hat, a hairnet like you would see maybe in food service, to prevent anything from coming off of you. We have these sticky mats. You might bring something in on your shoes, so you have to walk over these little sticky mats, and it is literally like double stick, large pieces of tape on the floor. You walk through that, and your footprints stay on that mat, and you don't take that dirt into our factory, which is evil. Chuck doesn't like that. The last thing that we have here before you go in is you go through an air shower, which we'll have a video of. It's basically a tunnel that's blowing air on you, and it's trying to dislodge anything that you might have on yourself, and then it just basically falls on the floor onto these sticky mats. So here I talked a little bit about this crater testing. The strictest application of this process in the company, basically because of the processes that we have and what impacts us. We've taken it to the ultimate level where we test every person in every team every day. And we've put here that is not without cost, but it's very, very beneficial to find a problem on some individual before we find it on the panels, because that gets to be very, very expensive. So here we go, and I would like to add, Chuck Valentini volunteered to be the model for some of the videos here. You're free to give us any feedback as we watch these videos. So this is Chuck coming in the plant, already has his what we call his blues on, and then going through the, that's the entrance. You can see it's a double door entrance, so it's a little bit of an airlock. Already has hat and the blues. And then this is the air wash, where all those little silver nozzles are blowing a lot of air. If you look close, you can see his clothing is kind of wind struck. And then as you walk out, then you're into the plant. You can start seeing some cool stuff. And then you see Chuck. He's kind of happy right then. It's like, because you just did what you were supposed to do. And I would say there really is no other way to get into the plant unless you go through that airlock station. Of course, there's emergency exits, etc., but we very much take that seriously. You got to go through that. Okay, so now we get to the point where we have this 800,000 square foot facility. And then remember, there's multiple levels, so you could really multiply that if you like. Here we have the overall process, and it's probably difficult for you to read some of this, so we're going to just walk through it. This is a graphical representation of where the things are in the factory, and it shows some of these VDLs, so you have to imagine maybe the parts are going this way, and then then they have to go up, they have to go over, they have to go down. So I'll walk you through that. So in the upper left, in your upper left where it's green, you see that little star. That's where the panels come in, and the panels, at that point, they've been primed at our supplier, but they've just basically come in off of a truck. Immediately after they come in, the first thing that we do is that we wash them. So we spray water on them that has some cleaning agents in that, and then the parts are wet. We then have to dry them. As we move through, then the parts have gone through up and down some VDLs. We are then priming the parts with a very special primer that is used in our factory that has a conductive component to it, so that we can help adhere the layers of paint that are put on afterwards using electrostatic processes. So then we go to priming. Every one of these little red boxes you'll see that are VDLs. So once again, this is a two-dimensional representation of a three-dimensional situation. Then we go up to one of the processes that nobody else in the world does, which is wet sanding the panels after they've been primed. You all in this room may be the first people ever, first time ever in public, ever, right, Chuck? To see video of what we are doing here, because we think it's extremely proprietary, and we went through a very rigorous process to make sure that we didn't disclose anything that would give secrets away to our competitors. So we wet sand the primed panels. Now, once again, we've created the virtually mud, the paint debris. We need to wash the panels again. We need to dry the panels again. And then we move over to this prep deck. And then at the very bottom here, you will see the three parallel processes that are all duplicates of one another. And the panels are on conveyor and on these scucks. They can go through any one of these panels or any one of these systems for painting, and they will go through the color application, and then the clear application, and then the ovens, and then they're put back into sequence. Because as you know, and we've talked about in the past, we build cars in the sequence, starting in the paint shop, of how they're going to be built. So VIN 1 is painted, then VIN 2 is painted, and VIN 3, and these go to general assembly in order. There's not a buffer where we store these. So then after that, we come up and we go into this resequencing bank, making sure that we get all of the conveyor carriers back in order. We go through a finesse process, and this is one where we'll show you where we're basically looking at all panels very closely. And if we see a spot that we want to polish a little bit, we'll do that. We go into panel exchange area, and then we do something also that no other car manufacturer does, is that we do what we call blackout. So at least in our company, we don't paint the undersides of hoods. We don't paint the undersides of other trunks in other vehicles, but we do that on the Corvette, so that when you open up the frunk or you open up the hatch, as it was with the C7 also, you see a nice matte black finish that is just appealing to our customers. And we're going to show you some videos of that also. It's really interesting and pretty labor intensive, to be honest. Last thing we do is we go down this VDL, and then you can see that we have made a complete clockwise circle with a couple extra twists, and now we're into an area that we call panel unload. The giant black line that is right to the right of that panel unload, that represents the wall going, that is really the start of the paint shop. So the loading and unloading of all these panels technically is outside of the paint shop. All right, so I've already given the answer away to this one. So who was listening closely? What does VDL stand for? Gary. You are the winner. And I'll have to make a note to myself, don't give the answers away before the questions. But Gary was, was paying attention. So here we go. This is a video of the vertical displacement lift. And to gauge a little bit about what's going on here, imagine that every color represents a different car. Perspective is kind of difficult, but these are, like I said, each one of these carriers is about the size of the stage and almost as tall as the screen there. And every different color represents one of those. So here you go. These VDLs have to be pretty substantial. You're moving a large amount of mass and you're moving them relatively quickly. Here you have a torch red car, white car that's going into the VDL. The mass of the panels? Chuck, would you know?
Yeah, it's not the panels that have the weight on this, it's the scuck.
It's the scuck. It's all the steel.
That scuck is very heavy, right, because it's got to absorb all the oven cycles. So that's what is really, the weight of the car is not what's heavy on it, it's the scuck. To the panels or the carrier?
We'll get back to you, Gary. I would say that the weight of the panels, I'm going to estimate it's less than 100 pounds. It's the weight of the panels on the car. If you would like, when you're done, you can go back and you can pick up one of these. They're just a few pounds. That's one of the things that makes this car so lightweight, is the composite panels. When you see these things in action, it's really kind of hard to gauge the kind of the massiveness of these things. You know, if this was in Cedar Point, you could pay people to have some pretty good rides on them. They're moving a lot of material in a lot of vertical direction here. Okay, and so what we have here, this is where we're loading the panels. So when we're doing that, look for these little clips and look for these golf tees, how we're using them. So these are the panels. That black color is the raw panel with just a very rudimentary prime. Takes two people to load the doors. You'll notice that the people aren't wearing these blue overalls because they're not technically in the paint shop yet. That individual, the man there, just put one of these little clips to hold the parts on. In this case, in every case, we strive to paint all of these panels in the position that they will end up on the car. So we put a quarter panel or a fender as it would be on the car. We put a hood as it would be on the car because how the paint is applied has a lot to do with its orientation. And if you had laid all those panels flat, then you might have horizontal surfaces that are now next to a vertical surface, and specifically with some of the metallics, it would give it a different look that when you paint the car in its original orientation, we can help with. Okay, so the body washers, lots of water is moving over these, 4 or 6 gallons per minute, so we're moving a lot of material from suppliers to the truck to the panel load and getting to these body washers. Here's a little video of what happens. Once again, these VDLs, and we have sped it up. Our operators are fast, but you saw the one walk away. They're not that fast. They're not as fast as somebody with a microphone around here recently. But these are the raw panels that are coming in, and then they're going to move through. It's difficult to see inside that washer, but it's spraying a lot of water and basically doing everything that we can to try to get as much dirt off of those panels in a very controlled manner.
Hey, Kai?
Yes, sir.
How do you recycle that water?
The water's basically in a closed loop system, so it's filtered. So we don't use it and throw it. It's filtered and then recycled. Of course, we have some evaporative losses that we need to make up some of that water, but it's basically a closed loop system. Okay, so we have this body here we go. What do we do with this body washer fluid testing? We have a number of things that we do where we're basically checking the chemistry of the water through some titration, through different methods to make sure that there's no bacteria and that the water and the washing process is doing exactly what we want. It could be the case that if you don't watch this, as any system, it can get out of control, and what you want to do regarding it helping the process, it could actually hurt. So here's what we have. This is an example of video. This is our technician bringing in samples from that water washing system. And we have kind of a mini chemistry lab here where they will take samples of the water, measure them to get the exact amount, and then move them over, decant them. Remember all of this from high school chemistry, and then go through a titration activity once again to determine the levels of materials, and then we can make any adjustments that might be needed.
And while you're watching that video, I will say that we do flush that water every week. So every week we drain the system on the weekends, clean it, and refill it. And it's a DI water. It's a deionized water. It's not just water that flows out of your tap.
So a lot of the, I would say that a lot of the processes that we have in the paint shop, that we have in the body shop, are very much exactly that. They are processes that we need to control. If we don't have pre-controls on any one of these processes, we will not be able to have any chance of having success at the end of the line with a high-quality paint job. Same thing in the body shop. Chuck happens to be the manager of both of those areas. You don't just start welding panels together hoping that is going to be okay. It's a very prescriptive process. The process controls are very rigorous, and this is just another one of those examples. Okay, here we're back to a little trivia. I've mentioned in the past that we have more than one prime color. We actually have 3 different prime colors that we use. Anybody care to, can you name all 3? Anybody name all 3? I think I heard every answer, and I have no chance of finding out who did it. So I'm going to ask whoever got them all right. I'll tell you. The answers here are red, white, and gray. Did anybody get all of those? I wouldn't know the difference. You could just raise your hand and you'll get something. All right, see, there we go. And every one of these colors is used for a specific top coat color. So just as an example, you can imagine what prime color goes under white. White. What color goes under red? Red. And what color might go under orange? Might be red, might be gray, might be white. So this is one of the things that Chuck has to do. He has to figure out exactly what would be the best prime color that goes on underneath any one of the top coats. And sometimes what our paint engineering recommends, we find a different solution that can yield a better result. So we have 3 different colors to choose from, other than just what you might think as a gray or this oxblood red. All right, and here we go. Here's a little video. On the top of the video screen, you'll also see this herringbone. We're just going to walk through the process. This is the robotic spraying of the prime color. Of course, this is a white, and those are the fascias, and you can see, these are sped up, of course, but you can also see, you know, kind of the looking into that spray booth. You notice that all the robots are covered in a material. It's not like the blue coveralls, but it's a very flexible and very lint-free, and I would say also very expensive cover that has to be highly flexible to articulate these robots in ways to not only spray one side, but you have to reach around and spray, for example, the inner part of a door. So you have to have a high level of articulation in these painting applications. So the next thing that we do is we have, after the prime, the painted parts then go through an oven. There's 3 parts to the oven. One is kind of a let's get the temperature started, and then we reach a certain temperature. We hold that temperature for a period of time, and then we control the temperature that drops before the part goes out. So it's not just paint a part, let it sit around for a little while and let it go. We're very prescriptive in how that works. Here's an example of we're skipping forward here, and I do want to take just a moment to reiterate that, you know, one of the main reasons that we have such a fantastic paint job on the Corvette is exactly what was done here. We're going to quantify it a little bit in some generalities at the end of the presentation. But this is one of the magic things. How many people have heard that people wet sand cars, that maybe they're hot rods or something, and it's really expensive? Typically when people do that, you're sanding the color or maybe the clear. We're sanding the primer, and there's some reasons that we do that, and you're going to see a little glimpse of what we do. And like I said, this is very much industry leading, and one of the main reasons why we have such a great finish on our car. So this is that would be a gray primered part that is coming in. And if you look very up, right at the top, see the water that's splashing? Whoops. Let me go back here. Okay, I won't touch it this time. And you can see this robotic application where there's a robot that's up there that is sanding the part. I think we might have a little problem with this video. Rachel, are you back? Is this what we're supposed to be? No, we'll take a look at this. Okay, maybe we'll have to come back to that. So that was kind of anticlimactic, where we said this is a big secret and we're going to show it to you for the first time, and then we don't show it to you. I think we've got an updated version. At the very least, when we're done, we will go back and make sure that we have the latest and greatest. Or if we have to take a brief intermission, we'll do that. Okay, then after this, we have made debris by sanding the panels. We need to get that debris off, so we once again are cleaning that, and then we get to the point where we're adding color and then heating and cooling. We'll watch this video. Once again, you can kind of see that this is a door ring, and it's kind of up in a position where we are spraying the color. Here we are spraying the doors. It is the case that we do share some pathing for common parts, or at least if we have a new color, we might start with a robot path that we think might work, but we almost invariably end up with having to make fine-tuning measures, which means it's almost always the case that every color has its own very own robot path. So when somebody says, hey, Chuck, go ahead and add another color to the paint shop, it's not just load panels and load paint. It's a whole developmental process where we have to go through and spray paint and see what we get, and then make improvements from then.
Kai, if I could, one quick trivia question. If you went back to that previous slide, that's a bell at the end of that robot that sprays the paint. A good trivia question for you is, how fast do you think that spins? I haven't heard. It hadn't been high enough answer yet. So who said 50? It's between 50 and 55, depending on the color, and so that's how fast that bell is spinning. So I thought,
Yeah,
that's pretty good, right? That thing is going that fast, and the purpose of that is to atomize the paint, right? So then it lays down how we want it on the vehicle surface. So we'll get you a prize.
Right. Thanks, Chuck. That's interesting. Okay, and now here we go into the color booths, and what we're showing here, once again, we have Chuck. He's walking into the area where we have kind of the control areas. Once again, this is a highly restricted area. Only people that have business in there go in, and you can get a glimpse of some of the controls that we have. Of course, it's all this automation is controlled with robotic control here with this control panel. We have all the colors, we have all the parameters, we have all the checks and balances, and it's the responsibility of the robot attendants that are in this area to make sure that everything is going on the way that it should. So they can actually see in there. The glass might look like it's a little bit distorted because there's actually a film on the inside. If there wasn't, of course, there'd be some paint that would get on that glass eventually. It wouldn't be able to be seen through, so that has to be periodically replaced so that operators can see in. Inside our mix room, where we have all of the various 12 colors, Of course, we also have we have clear and we have tinted clear, and then we have all the primers. So we have a lot of different paints that are inside the paint room, and we need to control the chemistry. We're checking viscosity, we're checking and validating that the colors are exactly the way that we want them. And then there's other parameters that we check based on the colors that we have. All that is done here, and here's an example of kind of the day-to-day operations of an individual coming in, bringing the materials, the various paints, and then you can see all the different colors that they have in the different little beakers or containers. And as they get ready to make their checks, they grab the different materials, make sure that they're prepared. And then start doing some various testing.
So we're maintaining shear, we're maintaining viscosity, we're maintaining temperature, we're checking chemical disposition, all of that so that when we spray out at the end of the robot, it's consistent, right? Because we want to maintain this this paint when it's in our system. We have systems that are designed to maintain it at all of those parameters, but this is us verifying that the system is doing what it's supposed to do so that we can find an issue before we find it in the painting process. That's why we have these level of controls, right? So that we find it before it becomes an issue on the vehicle.
Right. So that test that was just done was a viscosity measurement, where we're just basically trying to measure call it the thickness of the paint. Obviously, if we have big changes in that viscosity, then of course it's going to cause problems, and it's going to be inconsistently applied. Chuck, you might have to answer that probe.
So with this probe that you're in here, there's a couple things we're doing. I'll give you the easy answer. The one I'll tell you is temperature. There's a few other things we're doing with it too.
What's the material called that you make the pants out of?
It's an SMC material. So it's a SMC. So those panels are made, it's a really kind of an interesting process. You have a raw material. It's kind of, if you could imagine a fiberglass infused with resin material that's almost a blanket, you can take that blanket and you can cut it into pieces that, various thicknesses, various sizes. You place them into a die that is the exact representative shape of the panel that you're trying to create. You put these charges in the die. When the die is open, the die comes down, and boom, within a second, that material is spread around the whole panel. It's held there for a period of time. The machine opens up, and now you have a panel that's ejected. It needs to be cleaned up and prepared, but it's a pretty magical process. It is not what you might remember back in the old days where fiberglass panels were made with chop guns and things flying all over and resin squirting everywhere and everybody's all itchy and whatnot. It's not like that at all anymore.
What does SMC stand for?
Chuck, it's
Yeah.
sheet mold composite.
Sheet
Yeah,
mold
that's right.
composite, which is what it.
Sheet molded composite. Yeah,
right.
you start with this sheet and you take
That's
it
what
down
it is.
and then mold it, and then you make this composite panel. Yes. So the question is, when you switch from one color to the next, and we don't build in our old shop. We used to build in batches. We have the ability to spray color after color after color after color without changing anything. The change in paint, if you can imagine that robot with an arm, the valving is at the very end, close to that bell that Chuck described. So the valving is right there. So when we change a color, we change the valve. We do go over and spray the old color out. It's dots or drops of that, and then it's in a little bit of a cleaner, and we can come and then switch over. So we don't need to run in batches. We can run however we would like. And that's a big change over the old shop. The old shop, those valves were maybe up in the shoulder. You had to drain all the paint out. Incredibly wasteful. but the technology wasn't available to do anything else. That's a good question. That's how you save money, is to not waste paint. It's not cheap. Okay, ovens. Ovens are very, very important. It's not just putting the paint on the car or on the panel. It's what you do after that makes a big difference, especially in our composite panels. So we have two words, and it kind of defines the perfect cure. There's little chance that you can get this one, so I'm just going to go forward. Oh my gosh. That's because I already went too far and I went back. Once again, failed again. Okay, low and slow. So what does that mean? It's not like we're cooking ribs in a smoker, but it's kind of the same. Our panels are, just as we've described, where you're taking this liquid and solid and you're creating this panel. It is a phase transformation process. So if you would take one of those panels that you have freshly applied the paint, the color, and then the clear, and put it into an oven that has a very aggressive temperature, the composite material could have the tendency to move from a solid to a liquid to a gas. And then what happens? Where does that gas go? That gas comes right outside the paint that is maybe in a semi-solid form. So that is exactly what we do not want to have happen, and we need to control that. That means that we want very low temperatures. So if there is any type of a phase transformation, we reduce it as much as possible. And because we have a very low temperature, then we want a very long temperature. So it really is kind of very similar to what you would do by having long, slow cooking of meat, where it does basically the same thing. It just makes sure that you don't have an aggressive approach. That's very different in what we have in other metal-bodied shops, because you can really just put as much heat to it as that you would like. The other thing that is very important is that phase transformation also means that you want the paint to cure, to dry, maybe is an easy way to describe it, not from the outside in, but from the inside out, so that you don't create any other quality problems. So there's a lot of reasons for that, but this is ovens, low and slow. Thanks for everybody looking forward. And here we go. This is an oven. And what you see here is you see the very close proximity to all the nozzles that are in there, and it's really a convection oven. So we're moving air, we're forcing air around the part. We do a lot of things to make sure that the oven temperatures are realizing exactly what we want. So there is testing. In fact, if you look right on the front there, see that little thing that looks like where maybe the rear view mirror should be? That was actually a thermocouple. So what we end up doing is running these thermocouples through the ovens to make sure that we're getting a temperature curve that we would like, temperature going up and then going down. It's not just the temperature of the oven, it's the temperature of the oven that induces a temperature into the part that is important. The next thing Chuck, can you take over for a second?
Sure. So this process that you're getting ready to see here is the finesse process. So after the car comes out of being baked, goes in that resequence bank, it comes up here to finesse, and there you see one of our team members. She's inspecting the panel, looking for any thing that might be a flaw or something that we need to polish out. And then there it is with her polishing the panel. So we do get asked sometimes, how soon can I polish my car? And there it is, fresh out of the oven, and you see us polishing it. So that means it's okay to polish it then. We do, cars do like to be outside for about 48 hours before we recommend a full polish on them. But we can polish them here at the finesse process. And then that's what we're doing, is we're just polishing any imperfection out. And that's what we do through that process that you saw there.
You know what's neat when you look at this video is that you see that white glove, and it almost looks like the technician there has a rag underneath their hand. When I first saw the video, it's like, they're really supposed to have a glove on. The paint looks so good at that point. It's really just the reflection of the glove that makes you think that there's a rag. Did anybody think that they had a rag underneath their hand, or was it just me?
That's right.
All right, thanks. Just me again. Yes, sir.
At this point, has the tin coat been put on or the
It's done.
Yeah,
Yeah, at this point
clears
it's done.
on.
This is really kind of the first, and the hope is that it's the final inspection for anything that we see in the paint that we might not like, and we have an opportunity to do a little bit of polishing if need be. So everything is applied at that point in time. Okay, and then blackout. Once again, this is a process that nobody else does, at least in our company. And we do this in the coupe for the hood and the hatch. In the convertible, we do it for the hood, the tonneau, and the deck lid. Any part that opens up that you could see, we make sure that we do this painting operation. We have to, it's very laborious. We go through miles and miles of taping off, because now we have a panel that has had its other side that is completely painted. Remember what we just saw. We had the parts. The question was, is it done? Yeah, it's done. Now we're going to flip it over, and we're going to tape off so that we don't get the black paint where we are on a finished surface, and we need to make sure that that is perfect. And then we need to spray it. It goes through an oven, and then we pull that masking off. We actually have, if you can imagine, like a large plastic piece that then we set down. The panel is set on top of that, and then we put tape around the perimeter and then wrap it around so that there's no chance for the color that we have, the exterior color, to get exposed to this blackout material. Let's take a little quick watch on how this looks. So this is sped up. On the right-hand side, you'll see these panels that are coming in. They're freshly painted. And here we go. That's a hatch, so there's glass back there. Need to do some taping there. And then this is that mask that I've described. We put the mask down, and now we have to make sure that we secure that, and anything that we don't want paint on is covered up. The part's flipped over, and now you can see some of the exterior color, that red, has bled in and around the back of the panel. So now we have to go around and very precisely, really within less than 1 millimeter, we need to trace around the painted surface. And it's not just one piece of tape that you can run around when you're running down all these different edges. We need to pull the tape into different segments and very skillfully drop that in. You can see that they're looking at that very, very carefully. Imagine that you have a painter in your house and they're painting the trim boards. If it isn't done perfectly, you're going to be able to see it, and that's exactly what we do not want to have happen. If you go out and look at one of the cars when we're done here, if you open up a hatch, you'll see how precise that must be when you see this video and what we must do for every panel. And again, this is every panel on every car that needs to be blackout. We have to go through this process. So now the operators, the two of them are moving that onto a conveyor, and you can see that yellow and black, kind of that herringbone. That's the drive for the conveyor, and the part leaves that area. And then you can see there's the carrier. That's the frunk and the hatch. They're going in, and now you're looking at it kind of from the end of the spray booth, where the robot, similar application in our others, is going around and spraying the black material, articulating around to make sure that we cover all the parts that need to be covered. You could see this question, or the question that Chuck brought up about the bell. If you can see kind of that spinning vortex on the end of that paint, it's pretty interesting. Question back here?
Guy, if I may, considering the amount of time it takes to do taping, you have more than one team doing that?
What you saw is the team, and it is it's a very labor-intensive, very costly, but to be honest, we have to do that because we don't want to open up a hood or a hatch on one of these cars and see what it looked like before, where you've got a bunch of overspray. There's no solution to put, in other cars you might open the hood and see maybe a panel or a cover or like an engine blanket. We can't really do that in these applications. You can't do it in the front because you need to seal the front kind of the cargo area, and around the back it's just too large, right? Just not possible. Believe me, we've had a lot of conversations about what could we do differently, because we want the best, but we always look for the opportunity for improvement, and we haven't found anything yet. I would say that Chuck and the team have done an absolute fantastic job. If you saw what we had to do when we started painting cars, it was much more laborious, and if you can imagine that mask that goes on the backside, that didn't exist, and you almost are using newspaper, it is to that level. There's been a massive improvement in efficiency. That used to be the bottleneck. It's very close to being the bottleneck, but Chuck's done a fantastic job of making improvements in that area. And he's dying to make a comment. Look at him.
I just wanted to point out that one of the things that we set as a goal of the new shop was to make this product more durable. So some of you may remember, if you have older versions of the car, the blackout was really a soft material, was subjective to more chemicals and things that you might get on it, whereas this material is a proper paint with a proper bake cycle, and we made it much more durable, and that was one of our goals for the shop.
Right. Thanks, Chuck. The problem with a finished color, number one, it's a couple processes. You have to clear it, you have to paint it, then you have to clear it. It has to go through the oven, and it's really, really, really expensive. We believe that the average customer would rather have that matte finish, because then it doesn't require a lot of maintenance. It actually is it's a good application. If you had a coupe, also, if you're looking through the rear of the car, it covers up. Doesn't create any shadowing or glare, so that's my answer for now.
And we'll take questions. We'll take questions more at the end, because we got a few more things to get through on time here. Then we'll do some more questions.
Okay, Rachel, can we? We're going to switch back and watch the wet sanding. Hold on for a second. All right, here we go. So now you see this panel come in. You see the robot coming in at the top, and what you have is a DA, dual acting robot. Here they're dueling DAs. That's kind of a neat concept, and they are running around and articulating on the various curves. Really, we don't want to get into a lot of the details. Like I said, this is the first time that anybody outside of the inside of General Motors has seen these. And it's a fantastic process. So what are you doing when you do this? You're doing a couple things. You're mechanically knocking down the high spots that you have in the prime, and then the other thing that you're doing is the easiest way to describe reduction in surface tension is what happens when you throw water on a highly waxed surface. You get this beading. What happens when you put water on concrete? It just flows out. It's wet. There's no beads or bubbles. You would rather have concrete, not from a surface to paint, but you don't want a surface that will create this high surface tension. So we change that so the paint can go right on and have a better chance of being flat. Here are the operators. There are spots where we can't use the robot for. It might be on an edge. We don't want to get any sanding on an edge. So the operators here will go and make sure that we cover up all of the areas that we can't get with a robotic process. And you can see a lot of water is being used, and then just as a reminder, after this process, we do go back and we have to rewash all the panels before they go in, and then they get the color added to them. Okay, we can ask her one question while we switch back, please.
How often do you have to change these sanding heads?
We really won't get into those details. I would say that the sanding, this whole process is also, it's very sophisticated, it's very complex, it's very costly, and once again, it's one of the things that's done to, I would say this, I'm not going to give you the answer. How do you change those pads?
Yeah, I know.
Right, and you're in a robotic environment. Like I said, like I've told many people in the past, how do you keep a plant manager in suspense? Tell you tomorrow. Okay, so now we're back to panel unload. So now what we have is we have all of the panels that have had the outside painted. If the inside needed to be painted, they have been painted, and we are simply, let's see. Oh, okay, so here we now, this is that same carrier sped up a little bit. It goes on a giant turntable, reminiscent maybe of what locomotives might use in the past. And we are loading all of the parts into the material conveyance device that would be appropriate for them to be brought to either the body shop or general assembly. So here we have doors, of course, and then those doors go away, and then they go up, and then they go get used in a different part of the plant. Okay, a couple other aspects. Just one second, I got to grab a couple things. All right. We have a couple things from an environmental standpoint that we think are really special, and once again, the only used in the Corvette assembly plant. We don't use any water. All other paint shops, at least in our company in North America, use water to collect the paint. We use a dry scrubber system. So what this is limestone. It's pulverized limestone. And if you can imagine this material where the air coming into the paint booths, there is some paint that isn't used, right? It's floating around. It's not on a panel. We have to get rid of it. We bring it down underneath the paint booth, and it goes through a fluidized bed. So imagine this stuff with air pumping up through it, so it's almost bubbling. The paint then goes through this fluidized bed, and those little paint particles attach to the raw limestone, and you now have a paint-free airstream. And this doesn't require water. It doesn't require a waste treatment plant. And when we're talking water, we're talking, thousands and thousands of gallons of water that are used. So this is very, very cutting edge. We also use electrostatic spray applicators for very good transfer efficiency. That's really difficult because electrostatic implies that you have something that conducts electricity. Plastic composite panels do not. The primers that we put on help with that, and that helps the paint adhere so it doesn't go into these systems. And of course, we have our whole factory is filled with LED lights for visual inspection. And the baking ovens that we have are also highly efficient so that we can save the energy.
I think, Kai, that limestone, just to mention, reminder, that goes out and gets recycled and made into cement. So the limestone with the paint on it goes out and gets used in the cement. So we don't send it to a landfill. It doesn't have to go out. We have 2 farm silos on the far side of the paint shop. One's got clean in it. One's got the recaptured limestone, and it goes out for cement use, right? So that's an important environmental piece of it as well, no waste.
Chuck, you might have just lit the fuse on a bomb because there's probably people out here that want their driveway now made out of this stuff.
They probably would.
No, it's not going to happen. But I think that the point, beneficial reuse is what we like to do in all of our factories. We don't like to use cardboard. We don't like to use things that have to then be thrown away. And if we have to if we can reuse them, that we would like. And in this case, we turn something that's a really easy commodity to have. There's a little bit of limestone, especially here in Kentucky, and then we can turn it into something that everybody needs, and it has no negative impact. Somebody was going to take limestone anyway and turn it into concrete. Let's put a little step in the middle of it that makes some sense, and then use beneficial reuse. It's a great process. Thanks for bringing that up. Okay, and then a little bit about some of the measurement techniques on the outside of the car. This is a quote that is, maybe you've heard this before from Lord Kelvin. To measure is to know. If you cannot measure it, you cannot improve it. So when people refer to orange peel is this nebulous term. People look at a car, it's like, oh, that's got a lot of orange peel. That's a highly quantifiable process for us. And what you can see is that you have a laser, the blue at the bottom, laser bounces off the surface, which is that's an exaggerated shape of the surface of the paint, comes up to an optical receiver, and then we can generate this profile. We quantify the definition of orange peel, and we do that electronically. It's highly repeatable, and we can also then make comparisons to our different parts on the car, a lot of different parts on the car, horizontals, verticals, this part, that part, and we can also make comparisons very quickly to our competition. Wave scan is also another application where we're using a similar process that then goes through a series of filters that then determines various wave scans, and these are all the tools that we utilize to help make process improvements. It is the case that all these process improvements, they come from exactly this: measure, repeat, measure, try, and it is a little bit of exactly that, some trial and error. There are some cases that, as Chuck's team has enunciated, that we think that we really understand the physics of paint application, and we try something that we know that has worked in the past, and then we find out a new paint doesn't exactly react like the old paint, and we have to continue to learn. So it's a never-ending process. So without getting into a lot of details, Chuck did a fantastic job of taking a way to articulate how much better we have got for all of you. When we were in our old paint shop, and in 2017 we went to the new paint shop, all C8s, if you remember, then would have been started in the new paint shop. We had a roughly 25% improvement in the surface finish at that point, and we haven't given up. We've made another 8% improvement to where we are right now, and we're consistently bringing in new colors, and you've all have seen this new car that has one letter and two numbers that Harlan would like to answer questions about later. This is also another challenge because it could be that the shape of the exterior of the car might change, which then gives Chuck another burden to go figure out. Interesting information that Harlan, did you happen to share this that just recently? Okay, so maybe there's people that didn't see Harlan's presentation. Just a few days ago, the Corvette got the J.D. Power Initial Quality Award. We're really happy about that. Also, the Cadillac CT5 also received that same award. And why do we bring that in here? There's one connection point that we're really proud of. That CT5V Blackwing gets his engine from where? Bowling Green, Kentucky. It's got the LT4 engine in it. So in our own little way, we're contributing to not only the success of the Corvette, but also the CT5V Blackwing, which is an absolutely fantastic car. Okay, we have one more surprise that Chuck is unveiling here, and he is going to bring that up and show all of you. What this is on your far left, that is the base panel with the primer from our supplier. You'll notice that there's a little imperfection in that because they find little things also that they need to repair, and that's okay, but this is what you might look at. Then that second gray color, that's the primer that goes on the car. Then the next step there is the color, and then probably like 2/3 of the panel then has the clear on it, a little bit more than half. So what you can see is how that paint application works. The base prime that comes in from our supplier, we wash it, we prime it, we sand it, we wash it, we apply color through an oven, apply clear through an oven, finesse the part, making sure that the part is as good as it can, as we know how to make it, and then it goes to general assembly for production. Okay.
I think on that panel too, since it's red mist, which is a tint coat, it shows you how much more the clear is influencing that color position. So you can kind of see that, right? It's not just a question of making it more shiny, which normally clear does. It changes the color position as well when you have a tint coat.
We have, Rachel just came up here and said that we're going to get kicked out of here. We got, like 8 minutes? We have 1 minute? All right. She is full of... Oh, look at that. She's just trying to smile. She's doing this. Okay, so I guess that I will wrap it up here. Chuck and I and others from the plant will be outside. If you have some specific question, I would encourage you to come and ask us. And we'll call it a presentation for today. Thank you for attending. We really like sharing the things that we're doing in the plant, and we appreciate all of you